When talking about computers and technology, you may often hear the terms bits and bytes. You might be curious about what they mean and why they matter. Well, you're in the right place. Today, we'll break down these concepts, explain how they work, and illustrate why they're crucial for digital information. Whether you're new to tech or just need a quick refresher, stick around as we delve into the details of bits and bytes. Let's start off with bits. A bit is the fundamental unit of information in computing, derived from the blending of the words binary digit. It represents the smallest possible amount of data capable of holding one of two values, either a 0 or a 1. In our previous video, we explained the basics of binary. We recommend watching that video if you haven't already, as it will help you better understand bits and bytes. We'll put that video in the description. Bits are often represented as small blocks, each containing a numerical value. Bits in isolation lack inherent meaning or significance. They are merely the smallest units of data in computing, represented by binary digits of zeros and ones. However, it is humans who assign interpretation and context to these bits. Through conventions, standards, and programming languages, humans establish the meanings of sequences of bits, giving them purpose and functionality within digital systems. Whether it's encoding text, representing colors, or executing complex algorithms, the value and interpretation of bits are determined by human-defined conventions and rules. Thus, while bits form the foundation of digital information, their meaning and utility are wholly dependent on human interpretation and application. Now that we know what a bit is, we can understand what a byte is. A byte is a basic unit of digital information that consists of 8 bits. While a single bit can represent only 2 values, a byte can represent 256 different values, from 0 to 255, due to the combination of its 8 bits. This expanded capacity allows a byte to encode a wide range of data, such as a single character in a text file or a small part of an image. Bytes are the building blocks for larger data structures and are essential in computer processing and storage, providing a more practical and versatile way to handle data compared to individual bits. We see that bits and bytes are essential for storing data in computers, but to store any meaningful data, we need much more than just a single byte. Naturally, bigger units have been created, such as kilobytes, megabytes, and gigabytes. These units provide enough space for storing large amounts of data. Each of those units has its own symbol. We'll start with a kilobyte, which is equal to 1024 bytes. A single kilobyte can store a surprisingly useful amount of data. For instance, it can hold a simple text file of around 1,000 characters, which is roughly equivalent to a short paragraph or a few tweets. Additionally, a kilobyte can store a small icon or a low-resolution image. The next one is a megabyte. A megabyte, consisting of 1,024 kilobytes or 1,048,576 bytes, provides a significantly larger storage capacity compared to a kilobyte. With a megabyte, one can save a plethora of text documents, including essays, articles, or even a short novel. Additionally, it can store numerous high-resolution images or a few minutes of audio recordings. Moreover, a megabyte is sufficient to hold a simple computer program or application. While still considered relatively modest by today's standards, a megabyte remains an essential unit for managing and understanding digital data storage. And lastly, let's quickly look at gigabytes. A gigabyte, composed of 1,024 megabytes, or more than a billion bytes, offers a substantial leap in storage capacity compared to a megabyte. With a gigabyte, one can store an extensive collection of documents, including books, presentations, and spreadsheets. Additionally, it can accommodate thousands of high-resolution images, hours of audio recordings, or even several movies. Furthermore, a gigabyte provides enough space to install numerous software applications, including games, productivity tools, and multimedia editing software. As a result, gigabytes are commonly used in modern computing devices and storage solutions, reflecting the increasing demand for larger storage capacities in our digital world. As we conclude our exploration of bits and bytes, it becomes clear that these fundamental units form the backbone of modern computing and data storage. From the simplest binary representations to the vast complexities of digital systems, bits and bytes play a crucial role in every aspect of our digital lives. So, the next time you interact with technology, Remember the humble bit and byte, the unsung heroes behind the digital revolution. If you enjoyed, consider subscribing to our channel and liking the video. Thank you for watching.